Oh, hey, and welcome back to another Papetti Math YouTube video tutorial where I'm going to be teaching who? You, Algebra 1. And in this video, we're going to be looking at another type of regression. In Lesson 5, we looked at linear regression, where it was the line of best fit. Well, in Lesson 6 in Chapter 12, we look at exponential and quadratic regression. These are going to take the form of a line, not a line of best fit, but maybe a curve of best fit. And that curve might fit an exponential function or maybe a quadratic function, which we've studied both of this year already. So we're going to take that knowledge, that prior knowledge on exponentials and quadratics, and even some on linear, and we're going to combine them all together right now to determine a line or a curve of best fit using our graphing calculators and our brains. So in Lesson 6, it says, linear regression is useful when the data fits most accurately to a linear function. However, data can take the form of exponential and quadratic functions as well. Hey, it's like I just said that. In this lesson, you will practice performing exponential regressions and quadratic regressions on various sets of data. So in exercise number 1, it says Miss Perez owns a chain of bookstores. The table below represents the number of new stores Miss Perez opens each year. Okay, so we have the year and then the number of new stores she has. Using t equals 1 to represent the year 2002 and f of t to represent the number of new stores, create an exponential. We're going to be creating an exponential regression equation for these data, rounding all values to the nearest tenth. So it says to use t equals 1 for 2002. So this is really going to be 1. And then 2003 is 1 year after 2002. So that's 1 year after 1. That's going to be 2. And then we skip 2004 and go to 2005. So this is going to be a 4. And then we have 2006, which is going to be year 5. And again, we go to year 2007, which will be 6. So we go 1, 2, 4, 5, 6. Very important that we take notice that we skipped year 2004. Otherwise, your data values are going to be different than ours. And our number of new stores are going to stay the same. So now we're going to need our graphing calculators. We're going to go to Stat and then click Enter for Edit and clear out anything you have in those lists. Again, clear Enter will clear out those lists for you, and you'll be ready to put in your own data values. So in list 1, we're going to put in 1, 2, 4, 5, 6. And in list 2 over here, we're going to put in 5, 11, 46, 88, and 193. Now that you have your list 1 and list 2 values in your graphing calculator, we now want to go back to Stat and over to Calculate. And you're going to scroll on down to where it might say something that looks like exponential regression. I see quad regression, cubic regression, quart regression, ln(x). Oh, power exponential regression is option 0 right there. So you're going to click Enter on 0, or you could just press the 0 key and it will take you there. And this is your exponential regression screen. Again, all this information should be correct on your screen as well. And you're just going to go down to Calculate and press Enter. Now what this does is gives you an exponential equation of a times b to the x, which you learned about in the previous chapter. And you can substitute your a values and b values into this equation. So rounding all values to the nearest tenth, so we're going to have not y equals, but f of t equals, because it says to use f of t right here, a times b to the x. So a is going to be 2.5 rounded to the nearest tenth, times b, which is going to be 2.1 rounded to the nearest tenth, to the x, but again, in this case, to the t power. All right, so that's all that we had to do for this equation. And this equation right here could model how many bookstores that Miss Perez is going to open in a given year. So you could substitute a 10 in here, and you could see the prediction of how many stores are going to be opened in this year based on the data that we already have. So this is one useful application of exponential regression equations. And in exercise 2, we're going to look at another useful application of it. So at this time, if this video was helpful, give it a thumbs up, and you could go on to exercise number 2 at this time.